Hello, everyone, and welcome to the first of our pre-recorded lectures. So the idea here is that these will be somewhat short videos that cover a topic, and then after each video, you would go take your Canvas quiz. So this first one is to introduce what data science is and to review a few interesting data science examples. So first of all, what is data science? Why are you all taking this course? Why do more than 400 people sign up for this course every single quarter? And one response here comes from the former chief data scientist of the Obama administration. And he and another author wrote, "Data scientists, it's the sexiest job of the 21st century." So this is somewhat meant to be tongue-in-cheek, but the reality of it is this course is incredibly popular. Data scientists enjoy their work. In fact, for the past 5 years on Glassdoor, data scientist has been rated the #1 job. And this is because there are jobs out there. People tend not to struggle too hard trying to get into the field. And once they're in the field, they enjoy the work that they do and they earn a good living. So it's been consistently the #1 job year after year. So what is it? Well, we're going to get to a definition, what my definition is in a second. But first, we need to look at some historical context. Now, data science hasn't been around for that long, but back in 2008, there was a blog post that posted the first of the now infamous data science Venn diagrams. And that's what you see on the left. On a blog post, Drew Conway came up with the idea that if you have hacking skills, math and statistics knowledge, and substantive expertise, that allows you to consider yourself a data scientist. So if you have some computational skills, some hacking skills, some ability to write clean code to accomplish a goal, combined with math and statistics knowledge, once you write that code and have the data, do you know how to analyze the data correctly and appropriately? And are you able to combine those computational skills as well as the math and statistics knowledge in some domain? This domain could be anything. Sometimes it's economics, sometimes it's business, sometimes it's something in the biomedical field. But you need to know something about the field in which you're going to apply these math and statistics skills and hacking skills. And the argument was that if you fall into having knowledge in all three areas, you can consider yourself a data scientist. After this blog post was published, there were many, many more Venn diagrams that came out, one of which became very popular with the idea that if you have computer science knowledge, also understand math and statistics, and have some subject matter expertise, you are a unicorn. And the argument was that there just aren't people trained in these three things. Sure, we have data scientists out there. Maybe they were trained as computer scientists and they've picked up the statistics along the way. But to get somebody with all three of these really doesn't happen very often. And that's why programs like the data science major here at UC San Diego, as well as data science courses, started to pop up all over the place. We wanted to train these unicorns. And the goal in this course is that you have the hacking knowledge, the statistical background, and some subject matter expertise that you can apply to the problems in which you are interested. That said, to get to an actual definition, I have a whole bunch of different definitions up here. I'm not going to read all of them, which means I don't require you to either, but I wanted to put up that some people think it's a concept that's going to unify a whole bunch of different fields. Some people think it's a coupling of scientific discovery and the practice of working with data. Other people say it's an umbrella term. Brad Wojtek's definition is up here, but my definition that I'm going to include here is the scientific process of extracting value from data. On the next slide, we'll talk about what the scientific process is, but the goal really is to use data to extract some value. That value could be a business decision. It could be research that gains us additional understanding. But the important thing here is that you're using data to answer interesting questions. What you see here is a diagram displaying the scientific method, and these images tend to all be somewhat elementary because this is something we are all taught in elementary school. And the reason we're taught there is because it really applies. The scientific method is something that scientists and data scientists use throughout their lives, their careers, and it's not just limited to school. So what we see in the scientific method is that things start with a question. Typically, you want to ask a question about something you're actually interested in answering. And then you formulate a hypothesis. You consider what your educated guess is, your best guess is as to what the answer of the question to the question will be. You then experiment and collect data. Now, as a data scientist, sometimes the experiment has already been done. You then get the data and use that data to answer your question. You analyze the data, draw some conclusions, and then communicate your findings. Sometimes this is in the form of a report, sometimes it's a blog post, sometimes it is a presentation. But the idea here when we're talking about data science is you're gonna use data to extract some value to answer interesting questions. And at the core, that is what data scientists do. They ask interesting questions and answer them with data. And that's what we're gonna ask you all to do throughout this course in your assignments as well as your project. So what if we were to step back and say, okay, what does it look like for somebody to do a data science project? Well, one, a question you could have as you walk down the street would be, what question should I ask on a first date? Now, there's a few ways you could approach this question. You could ask your best friend and they could tell you, and then you could just do that. Or you could take a data-driven approach. And that's what OkCupid did. So OkCupid was at one point the most popular dating app. It is no longer. But they, many years ago, posted a blog post looking at the way they would use their 275,000 match questions to analyze and answer this question. And the way OkCupid worked was you made a profile and then you answered a bunch of questions. All the questions were optional, but there were more than 275,000 of them, and some of them were answered by lots of people. And they could then look at the answers and the similarities between these answers to figure out what it is that's easy to bring up, but that also correlates with the deeper unspeakable issues that people care about, but that you can't ask on the first date. So they analyzed the data from their many, many users, and they first figured out how to filter their data. So they started with all of their questions and they eliminated the redundant or subliterate. So some of the questions on OkCupid just don't make sense, and some of them are duplicates. So they got rid of those. Their step two was to eliminate the too personal. These are the things that are taboo or you're not supposed to ask on a first date. The third thing they did was eliminate the too obvious. And then they had their set of some 50,000 viable first date questions. So that's what they did, and they determined through this analysis, if you want to know whether or not you and your date have long-term potential, you could ask them, do you like horror movies? Have you ever traveled around another country alone? And wouldn't it be fun to chuck it all and go live on a sailboat? And if you and your response, your date's answers agree, that suggests you have good long-term potential. So what they did was at the end, they came up with the 3 questions, and you can see up here, the percent of long-term couples who agree on all 3 questions is the dark blue, and the light blue is the percent of agreement expected by pure chance alone. So the top 3 user-rated match questions, what people say they care most about, are the answers to, is God important in your life? Is sex the most important part of a relationship? And does smoking disgust you? And you can see that the percent of long-term couples who agree on all 3 is somewhere around 15%. Alternatively, from their analysis, they recommend you ask, wouldn't it be fun to chuck it all and go live on a boat? Do you like horror movies? And have you ever traveled alone around another country alone? And if you agree on those, you are much more likely, relative to chance, to have long-term potential. So that's one way in which you can use data to answer a question that is interesting to people's lives. The second example here is a look at studying coordinated migration. Here, the idea that flow of a population from a city A, one's hometown, to another city where they currently live is considered a coordinated migration if, among all the cities from which people from hometown A now live, city B, the current city, is that with the largest number of people from city A. So it's a coordinated migration if there are a lot of people leaving one city and ending up in another place. And what someone decided to do was to study between city coordinated migration. They examined aggregate anonymized data for all users who list both their hometown and their current city on their Facebook profile. So again, there are a lot of ways in which you could analyze these data. You could survey people. You could collect information from some other source. They decided to use Facebook data to study this and understand coordinated migration. And what they have here is a map of the world looking at worldwide coordinated migration, where 2 points are connected by a line, and a abundance of lines would suggest similar migration patterns. And what they saw was that major destinations of coordinated migration tend to be in rapidly urbanizing countries. So you can see the places where people are tending to end up happen to be in rapidly urbanizing countries. They also saw that different types of international coordinated migrations have the United States as a destination. So Cuba and Mexico demonstrated the highest volume of coordinated migration to the US, where you can see a lot of coordinated migration from Mexico ends up in Chicago, and from Cuba in Miami. So you can see these patterns throughout the world. The third example that I wanted to give you all comes from the gig economy, and it's from Uber. And these data come from Professor Wojtek, who was the first data scientist at Uber and who is now a professor in the cognitive science department. And so the question you could ask yourself is, how do I improve ride sharing? Now, again, you could go talk to a whole bunch of people, or you could use data collected at the app that you're working at early on. And the idea here is, what if you wanted to understand rider patience? Right? What if you want to understand how long is someone on your app, a user, willing to wait for a ride? So what you're looking at here are some early Uber data where ETA in minutes is along the x-axis. So this is the estimated time of arrival that is told to the user. And then you have relative events on the y-axis. And you can see that the blue line are those that were completed, and the dotted line are those that were canceled. So you can see among the rides that were canceled, they tended to have longer ETA. So people were going to cancel if they were told that their ETA was too long. So you can then use this to figure out how long people are willing to wait. And what you have now on the y-axis is ETA decay and launch order. What they found was that the people in San Francisco, where Uber first launched, were willing to wait somewhere between 0 and 8 minutes. If it got much more than 5-ish minutes, people started to cancel their trips. And what they saw over time was that as they launched in new cities, people were less willing and they were less patient. They expected their rides to show up much more quickly than they did in the previous launch city. So they saw this shift over and over, with people being less willing to wait. So this look at the ETA and the relative events gives you an idea of rider patience without ever directly measuring patience. And we see that over time, people get less and less patient, such that over time in new cities, even within the same city, there's a shift in patience. Where in 2013, the orange dotted line, we could see that patience, the average was somewhere around 8 minutes. Rider patience shifted with the average down somewhere closer to 4 minutes just within a year. So people were expecting Uber to become more and more reliable. Now, I don't want to give you the idea that you have to use Facebook data, or you have to use Uber data, or you have to work at OkCupid to do data science. Data science is being used across companies in the world, including the ones you would think of, like Facebooks and the Googles and the Amazons, but also the smaller, now larger startups, things like Airbnb and Stitch Fix are all have large data science teams. And the idea here is it can be helpful in the business world to, say, track purchases and online interactions. It's also being used by governments to make themselves more effective and to improve system efficiency. Social scientists use it to identify patterns in human behavior, and economists and marketing individuals use it to determine the most effective advertising strategies. And that's the idea in this course, is that we are going to review the data science process, walk through all the steps so that you are able to use data science to your benefit. That's all for this first pre-recorded video. Don't forget to take the corresponding Canvas quiz.